Okay, so in the previous video clip we looked at Theta, and we might just download the file here. So to retrieve the Excel file, we click on the link. It brings us into the OneDrive. Because I'm not signed in, I probably won't be able to manipulate, and the data tables and that don't seem to be activated, so just download. And because some of the functions here in VBA also we have to enable content, and once we enable content then you can see the VBA is live, so that's fine. And to activate and to make sure that the data tables are activated, we go to the Data tab, What If Analysis, Data Table, and what we had done is rerun the estimation for the option value, which is 688 here, and for Theta, which was negative 8.11 on the call, and rerun it for each of these stock prices or asset values. So because it's a column, we select the option for the column, not the row, and then we click on the original parameter input that was used to generate these figures here. So we click on the 100, and you can see that our graph becomes visible. And the interpretation we offered here was that the Theta represents a measure of time decay, and as the time period passes, in other words, when we set the option up, it obviously has a finite life, and as the months pass, the remaining maturity on the contract diminishes, and the value of the option will, if the dividend is low, close to zero, what you generally find is the value of the option fall. So smaller, lower maturities produce lower valuations for the option, and as a consequence Theta can be generally negative. Now, on the previous video clip I illustrated, well, if we decide to increase the value of dividend yield, number lock, if I decide to increase the value of the dividend yield, then there may be a region where that's not so obvious, and if we go to 0.06 or 6% dividend yield, we find that the Theta actually can become positive, and that would mean that as time passes the option becomes more valuable. But that really is a result of the tapering of the time valuation that we would have seen in a previous video clip. So if we go back to come down to the option Greeks parameter sensitivities, and I think it was number 3. So let's try this one. And we saw that for different maturities the value of the option will tend to increase. So increasing the maturity tends to increase the value of the option. However, in this instance here, because we had a positive dividend 4%, the reference here for Q was 4%, that when we get deep in the money, the value of the option actually drops. Okay, so Theta really is describing this dynamic. What happens if you reduce the time period? And if you reduce the time period, the value of the option tends to fall. So there's a negative relationship. But that relationship can become positive, that as time decay increases, in other words, as the number of weeks or months passes and we get closer and closer to maturity. In this instance, we notice that increase in the time period can lead to a reduction in the value of the option. And when we compare time decay would be time passing. time passing leads to an increase here in the value of the option, in other words maturity falling, then we have a positive relationship. And we can link that back to what we have here, that for a range, when you're deep in the money, for a range of particular values, time decay actually leads to not a fall, but actually an increase. If there was no dividend yield, if dividend was 0, it's always negative. So by and large, we're expecting, for the bulk of the time, we're expecting a negative value for theta. Okay, so we can go back to the YouTube page and go to Vega 3. Oops. See, where's that? Vega 3, and just open this file up. And I'm going to use the rubric in that existing particular file. So I'll download here and just change the structure so that we have a similar organization of time and then numerical value for the option. Okay, so Vega 3 seems to be open, enable editing, enable content. And again, okay, let's set this up then as being, okay, let's just copy that and put into Theta 1, paste, and I'll call it Theta 2. And first thing I need to do is to rerun the estimate. So I want to create a theta that's analytical, an analytical theta. So theta based on this function here. So I'd say equal to, instead of the reference being C13, I'll go back C equal to C14. Then I will rerun this table. So recalculate the value of the theta for different inputs. And okay, so let's just try that. Data what if analysis. So data, and then to what if analysis, data table, it's a column, and original input for the stock price. And you'll notice that this is the same as, in fact I do it this way, this value is the same as the value here. So I know that the data table is right. Okay, so just to make that clear, let's highlight the color. And you can see for when the asset value is 100, theta is equal to -641. That's what I found here. And let's just take this out, because not the function here actually is this function that I used. Okay, so now what we've got is we have theta, and we worked out the analytical value based on the formula given in our VBA. So VBA for call is given as before. So we go back to the spreadsheet, and we're going to generate, as we did for Vega, we're going to generate a numerical Vega, theta. So here we had a numerical Vega, and we could see that under the right circumstances we could make the numerical Vega converge with the analytical Vega. So what I'll do is I'll take these values out. I'm going to use the same structure, in fact, but for the moment I'll just remove, and or I'll remove the numerical Vega at least for the moment, and I'm going to rerun the estimate, and instead of working on the basis of a particular volatility, what I'm interested actually is a level of time. And so we'll say t equal to, let's say, 6 months, and then t, the value of the call, where we're thinking of a particular t equal to 1.25 months. Okay, and we should have t, maybe t1 and t2. So we're thinking of 2 maturities, and we're going to rerun estimates. So okay, let's take this out. Let's just delete and build this from scratch, and we're going to say the time period is 1 year, 9 months, 7.5 and 0.75, and equal to the previous cell, and pull that down. And likewise for the longer time period, 1.25, and then all the other cells are equal to the preceding cell. So as I pull that down, they will all come up as 1.25. Then I take the value of the call. Now what was the value of the call? Well, the value of the call, just go back into our developer tab, the value of the call was given by this function here. So we can say, okay, let's take this and copy and go back into the spreadsheet, and we'll paste, and we'll say, okay, equal to the reference for the stock price, we're going to say is, take it as here. The reference for the volatility was 100, and we're going to lock that cell reference so it never changes as we drag down. The value for t, we're going to set for this shorter time period, 0.75. The value for r back here, and F4, so we lock the cell reference. The value for Q is back here, and I hit F4 to lock the cell reference, and it gets dollarized, as you can see. And the value for the volatility, if I highlight and go to take sigma as being V, and then hit F4, it dollarizes and return. And let's just pull that down. And we'll keep in mind this is for, should be 7.5, and this I'm going to take initially. We can change these values to be 1.25. Okay, so 9 months and 15 months. Now, is our calculation correct? Well, we could verify. There is a difference here. And that's largely because of the time period is 9 months. So if I change this to 1, so for instance, if I want to check, let's just check this value here against this value here. Okay, and we'll just put in blue or something. If I change this to 1, they should be the same. So return, and indeed we get the same result. Okay, so I've verified that I've made this calculation correctly. Okay, to run the second valuation here for the longer time period, again, everything is exactly the same, keeping in mind that the third value, if I just copy this, equal to copy, go back in, paste, and then again it's coming up as the same result, but I just need to change, remember if we double click here, notice that the purple here, the M3, is the third variable in its time. Let's change that to the higher time period. So it's N3 as opposed to M3, and it should be a higher value. And we'll pull this down, and I'll verify in the next